Thermal power plants help meet almost half of the world's power demand. They use water as the working fluid. Today's thermal power plants are capable to run under great efficiency by conforming to stringent environmental standards. In this video, we will see how a coal-based thermal power plant achieves this in a detailed step-by-step manner. By turning the shaft of this generator, we will be able to generate electricity. The generator derives motion from a steam turbine, the heart of the power plant. In order to turn the steam turbine, you have to supply a high pressure and high temperature steam at the inlet of the turbine. As the turbine absorbs energy from the high energy fluid, its pressure and temperature drop toward the outlet. You can take a closer look at the uniquely shaped steam turbine rotor blades. High-capacity power plants often use different stages of steam turbines, such as high-pressure turbine, intermediate pressure turbine, and low-pressure turbines. So now we have met our objective. We have produced electricity from the generator. If we can bring the low pressure and low temperature steam back to their original states, which were of a much higher pressure and temperature, we can repeat the process. The first step is to raise the pressure. You can use a compressor for this purpose. But compressing steam is a highly energy-intensive process, and such a power plant will not be efficient at all. The easy way is to convert the steam into liquid and boost the pressure. For this purpose, we'll introduce condenser heat exchangers which sit beneath the low-pressure turbine. In the condenser, a stream of cold water flows through the tubes. The steam rejects heat to this liquid stream and becomes condensed. Now we can use a pump to increase the pressure of this feed water. Typically, multi-stage centrifugal pumping is used for this purpose. That way, the pressure will revert to its original state. The next task is to bring the temperature back to its original value. For this purpose, heat is added to the exit of the pump with the help of a boiler. High-capacity power plants generally use a type of boiler called a water tube boiler. Pulverized coal is then burned inside the boiler. The incoming water initially passes through an economizer session. Here, the water will capture energy from the flue gas. The water flows through a downcomer and then through water walls, where it transforms into steam. The pure steam is separated at a steam drum. Now the working fluid is back to its original state, high pressure and high temperature. This steam can be fed back into the steam turbine. And the cycle can be repeated over and over again for continuous power production. But a power plant working on this basic Rankine cycle will have a very low efficiency and a low capacity. We can increase the performance of the power plant considerably with the help of a few simple techniques. In case of superheating, even after the liquid has been converted into steam, even more heat is added. And with that, the steam becomes superheated. The higher the temperature of the steam, the more efficient the cycle. Just remember the Carnot's theorem of maximal thermal efficiency possible. But the steam turbine material will not withstand temperatures of more than 600 degrees Celsius, so superheating is limited to that threshold. The temperature of the steam decreases as it flows along the rows of the blade. Consequently, a great way to increase the efficiency of the power plant is to add more heat after the first turbine stage. This is known as reheating, and it will increase the temperature of the steam again, leading to a high power output and greater efficiency. The low-pressure sides of the power plant are prone to suck the atmospheric air even with sophisticated sealing arrangements. The dissolved gases in the feed water will spoil the boiler material over time. To remove these dissolved gases, an open feed water heater is introduced. Hot steam from the turbine is mixed into the feed water. Steam bubbles so generated will absorb the dissolved gases. The mixing also preheats the feed water, which helps improve the efficiency of the power plant to an even greater extent. All these techniques make the modern power plant work under an efficiency range of 40 to 45%. Now we'll take a look at how heat addition and heat rejection are executed in an actual power plant. The cold liquid is supplied at the condenser with the help of a cooling tower. The heated up water from the condenser outlet is sprayed in the cooling tower, which induces a natural air draft, and the sprayed water loses heat. This is how a colder liquid is always provided at the condenser inlet. At the heat addition side, the burning coal produces many pollutants. We cannot release these pollutants directly into the atmosphere, so before transferring them to a stack, the exhaust gas is cleaned in an electrostatic precipitator. The ESP uses plates with high voltage static electricity to absorb the pollutant particles. We hope that we've given you new insights into the